NASA plans to build a base on the Moon before sending humans to Mars to shorten the process of reaching Mars. SpaceX founder Elon Musk wants to take the race to Mars, and the European and Russian space agencies are also talking about sending humans to Mars. But after landing in the harsh atmosphere of Mars, how will humans survive there? Because oxygen, the main necessity of life on Mars, is not available. What is NASA's way of making oxygen on Mars, and why the way the International Space Station makes oxygen won't work on Mars? There are many reasons behind the desire of humans to live on Mars, in which there is a factor of scientific exploration and space curiosity. But behind these desires, there is also a compulsion or fear. That is, the human race may not end due to a natural disaster like the dinosaurs disappearing from our world 6.5 million years ago. And it's possible that we're seeing an example of climate change on Earth. This is probably the biggest reason why someone will be the Neil Armstrong of Mars in the near future. On the one hand, Elon Musk first planned to colonize Mars in 2026, but now he has predicted 2029. On the other hand, NASA has also planned to land humans on Mars by 2030, but the question is not who will go to Mars first. The question is, how will humans be able to survive after going to Mars? Of course, Mars has many features similar to that of Earth, as a Martian day is only 39 minutes longer than Earth day. There are also different seasons like Earth. In addition, there are ice caps at the poles of Mars, and there is an atmosphere at the poles of Mars, although Mars has a thin atmosphere. But one thing that is not enough for humans to live on Mars is oxygen. So how will this oxygen gas be made on Mars? It is not for 1 or 2 people, but to keep a whole colony of Mars alive in extreme situations. So the first thing that comes to mind is the International Space Station, ISS, which has spent 25 years in the harsh conditions of space today. And until now, it has been continuously supplying humans with oxygen and fresh water, with 4 to 5 astronauts aboard the International Space Station at all times, whose daily requirement of water is at least 45 liters, which means 1,350 liters per month and 16,200 liters per year. In addition, 1,000 kilograms of oxygen gas is used annually on the ISS. For this purpose, ISS has 2 systems. One is a water reclamation system, and the other is an oxygen generation system. To understand why we can't put these 2 systems on Mars, we first need to understand how these systems work. The water reclamation system collects water from human waste, urine, sweat, and humidity, and then cleans it and makes it drinkable again. The system purifies the water already on the ISS and makes it reusable, thus avoiding 98% water waste. Just like that is the oxygen generation system. This system takes a small amount of water from the body and then passes it through a special process to produce oxygen for breathing. This simple process is called electrolysis. An electrical current is passed through water, which turns the water into oxygen gas and hydrogen gas. Oxygen gas is used for breathing, but hydrogen is a very dangerous and inflammable gas that can burn up the entire ISS in seconds, creating a fireball. This hydrogen gas is not wasted, but is pumped into another system called the Sabatier system. The system collects waste carbon dioxide from astronauts on the ISS and mixes it with hydrogen gas to make water, methane gas, and a small amount of heat. The water is recycled, and the heat is put into the heat management system. Methane gas, which has great importance on Earth, is ejected from the ISS into space. Methane gas, which is also a type of fuel, can be used to create energy and heat, but it is wasted for this reason, because it needs oxygen to burn, and oxygen is the most precious thing on the ISS. Considering the ISS's entire oxygen and spacecraft processes, they depend on refueling missions, because of course they are 98% efficient, but still, there are losses and leakages in every system. For this reason, every 6 months or years, water and oxygen are brought from Earth and put into the ISS. These refueling missions are very costly, in which the cost of transporting just 1 liter of water to the ISS up to 400 kilometers is more than $2,500. Therefore, Making oxygen in the same way on Mars, 22.5 million kilometers away, is not cost-effective at all. For Mars, a system has to be built that uses the resources on Mars itself to make oxygen from it. NASA's Perseverance rover sent to Mars in 2021 carried a device for the same experiment, which has been named MOXIE, means Mars Oxygen In Situ Experiment, because in ISS there is a source of water refueling, but to find water on Mars, you have to go to its polar caps or drill several feet down to extract ice. Because of this, MOXIE uses carbon dioxide from the atmosphere of Mars to make oxygen from it. To put it simply, the atmosphere on Mars is 95% carbon dioxide. MOXIE pumps in carbon dioxide from the outer atmosphere to pressurize it. Then it is put in an electrolyzer and heated to a temperature of 800 degrees Celsius, from which oxygen gas is separated from carbon dioxide. This electrolyzer is made of gold because gold is an excellent heat conductor that protects other parts of the preserver from overheating. In this process, oxygen gas is produced from carbon dioxide as well as carbon monoxide. The disadvantage is that if the carbon is completely separated in this process, it can also form a layer of carbon as seen on the bottom of a cooking pan, and this layer will not last long enough to damage Perseverance. That's why this process is performed with great care. But how much oxygen does MOXIE produce at one time on Mars? This process requires a lot of energy for MOXIE, which is why it is only run by NASA when solar panels are left with extra unused energy. So far, it has produced only 122 grams of oxygen, which can keep a human alive for only 3.5 hours. If the same system were to produce more oxygen on Mars, it would require a larger version of the MOXIE, as well as a larger power plant to run it. And this is by far the biggest challenge. To solve this problem, scientists are working on a future technology in which carbon dioxide molecules can be broken at low temperatures, not by heating the carbon dioxide instead. Oxygen molecules will be separated from it by creating fibrillation within it. Currently, this technology has been tested in the lab. Due to the high atmospheric pressure and temperature of Earth, it is not possible to do this experiment on Earth, but the atmosphere of Mars is absolutely perfect for this work. Whatever the technology, our goal is to make oxygen on Mars using whatever is on Mars and the device that will make that oxygen. Their dependency is not even on Earth, because the ISS is only 400 kilometers from Earth if its oxygen generation system fails. So sending the astronauts back to Earth is not that big of a problem. They can wear their emergency suits and wait for refueling for a few hours and go back to Earth. But if there is a problem with the oxygen generation machine after colonization on Mars, there will be no refueling option, and it will not be so easy to return to Earth.